Okay, this lesson we're going to explore limits going to infinity, okay? Or possibly negative infinity. So if we take a graph, okay? And let's have this graph something like this. As x approaches infinity, okay, what is happening to the y? So as x gets bigger and bigger and bigger, what's happening to the y? In this case, it's going to be growing higher and higher and higher as well. So in this case, my y is going to approach infinity. As x goes to negative infinity, so as x gets smaller and smaller and smaller all the way down to negative infinity, what's happening to the y's? In this case, the y is going to approach negative infinity. Okay? So that's what we're going to do. We're going to approach infinity and we're going to approach negative infinity and we're going to see what happens to the y's. Okay? A lot of times it's going to be with an equation. Limit as x approaches infinity. And you might have to do some magic. Maybe you could graph it out. Okay, this is a reciprocal function. I can graph it out and maybe visualize what's going on. Now in this case, as x approaches infinity, the y's are going to get very, very close to 0. Y is going to approach 0. Okay? So in this case, it's going to equal to simple 0. As x gets really, really big, the y is going to approach 0. Sometimes you might have a little bit harder ones to graph. So fortunately, there's some rules I can follow. If I look at the degrees, so the highest exponent of the terms, okay? If my degree on the denominator is greater than the numerator, so for example, in the first one here, I have degree 1 over degree 0. The limit as x approaches infinity is going to equal 0. If my degrees are equal, so for example, in the second one, the degrees are equal. Both of them are quadratics. They both have the highest exponent being 2. Then it's going to be equal to the fraction of the leading coefficient. So here, my leading coefficient is in front of the squareds. So as x approaches infinity, my answer is going to be 2 over 3. Well, how does that work? Well, as x approaches infinity, x is going to get super big, big, very big. The x squareds are going to be the things that change the most on both the top and the bottom. As the x's get really big, the x squareds are going to have the greatest impact on the equation. Really, the rest of it is going to have minimal impact at all. So eventually, it'll just simply whittle down to just the fraction 2 over 3. The limit as x approaches infinity, and you have, look at this one right here. What rules are going to follow? Well, these are both to the exponent of 1. They're both the highest degree 1. So it's where the degrees are equal, it'll be the fraction of the leading coefficient. So the fraction on those highest degrees, which is a 1 over a negative 1. So it's going to simply equal eventually 1 over negative 1, which is just simply negative 1. If the degree on the bottom is greater than the top, it goes to 0. If the degrees are equal, okay, it's a fraction of the leading coefficient. Actually, if the degree on the top is bigger than the bottom, it actually just keeps on going to infinity. It has no limit. Okay, so graphically, take a look at this graph. As x approaches infinity, what's going on to the y value? Well, really, my y value is also going to approach infinity. As x is getting really, really big, so is my y. And if I look at if x approaches negative infinity, so I'm going to negative infinity, what's happening to the y? Well, the y's are just going to get really close to that negative 2 asymptote. Y is going to approach negative 2. Okay? So this is just a quick little lesson on as x approaches infinity, what's going on, the limit as x approaches infinity. Thank you very much.